Can they switch this? No, you want them to do
I don't think they can, right?
Are you projecting with this?
No, with this.
You want to do the third? I mean, at least you get the next slide with
I prefer without it.
Yeah? You want to run it, so you want to let them run it?
Yeah, I'll run it to them because God knows what is. You see my point? It's security. The funny thing is that I'm used to look here and you have to look there now. It's good that we have this screen at least.
Good morning, everyone. So we're going to get started on INTAREA. Welcome, INTAREA at IETF 99. Blue sheets are going around both sides, so please make sure you register your agenda. Your dear chairs, Wasim and myself.
Hello, everyone.
There's a new note well that you have already learned by heart at this time of the week. So we encourage you to keep reading it and be aware of the differences. Basically, you have to disclose any IPR related to any discussion, communication, etc. that happens during this meeting that you may be aware of. So we have a minute taker. The meeting is recorded. We will get the scribe to get the notes eventually to the Etherpad. And everything, of course, is public. So once again, please go with the blue sheets when you see them. We have blue sheets going around. We have note taker. Do we have a jobber, scribe, or someone that could volunteer to help us with the jobber? Just for the Q&A part. Anyone? Yeah. Please. Anyone that is willing to stand up?
Yeah. Thank you.
Thanks. We got to. Perfect. Thank you very much. All right. So moving on to the agenda, we're going to give you a quick update on the working group documents and where we stand. Then Ron is going to give us his speech about probe, which is a EPING, the old EPING. Now it's called probe, and it's been accepted. Congestion notification, tunnels with Bob. Tal is going to talk about guidelines and for packet, discovering provisioning domains. Eric, MPT network layer from Gabor, and SOX v6 from Vladimir. On our status update, the privacy considerations for IP broadcast and multicast protocol designers, well, if you remember, that document got accepted. So a shepherd has been assigned. That's myself, actually. So I'm going to be shepherding the document now. On the generic UDP encapsulation, it's been updated to version 4, but the authors No, sorry. So the only update is it's moved from version 1 to version 4. No presentation planned for this time. On the IP or intentionally partially partitioned links, we adopted the document as last time, so it's now a working group document. Again, no presentation. Probe got adopted, but we will hear an update from Ron directly. And IP tunnels in the internet architecture, we decided on the list to move it in the shape of BCP, but the authors did not have a chance to make an update before this meeting, so they will do so after the meeting, and we will continue the discussion on the mailing list.
Oops. It's not. That's it.
So I guess the next one is Ron.
Yeah, of course.
Okay. Welcome to Thursday morning in a cold, dark room. I'll try to wake everybody up. You've heard this presentation before under different names. First time I came here, it was called ePing. Then we had to change it to XPing. Then we found somebody else had used that. So now it's called Probe. One thing that's changed significantly is the name. A feature has been added. And just to make sure that you're all awake in this cold, dark room on Thursday morning, when you see the new feature, raise your hand, and then I'll know people are awake. Anyhow, let's dive in. Probe is a utility that feels something like Ping, but a little bit better. Let's go on to the first slide. And let's talk about your old buddy Ping. Ping tests bidirectional connectivity between a probing interface and a probed interface. Probing interface sends an ICMP echo request to the probed interface. If the probed interface gets the request, he sends back an ICMP echo reply. And if the reply makes it all the way back to the probing interface, we declare success. Otherwise, we declare failure. Now, something about Ping. Ping doesn't always exercise the probed interface. The echo request may come in the probed node through a different interface, and the echo reply may leave the probed node through an interface other than the probed. So, first thing you have to disavow yourself of is the notion that we're exercising the probed interface. Next slide. Ping has two failures. Not two failures. It does what it does. It has two shortcomings, though. One is it can't distinguish among the following failures. Maybe the echo request got lost on the way to the probed node. Maybe the probed interface is down. Maybe the probed interface is up, but the echo reply got lost on the way back to the probing interface. In any case, when you look at Ping, all you know is that the echo reply didn't make it back to you. You don't know why. The other is that Ping requires bidirectional reachability between the probing and the probed interfaces. So there are some times when you just can't use Ping. For instance, when the probed interface is unnumbered. When the probing interface is IPv4 only and the probing is IPv6 only, or vice versa. So with Probe, we're going to try to overcome the shortcomings you see on this slide. Next slide. So let's talk about Probe. What makes Probe different is it distinguishes between a proxy and a probed interface. What happens here is the probing interface sends an ICMP echo request to a proxy interface. That's a new ICMP message. The extended ICMP echo request identifies the probed interface by address, IF name, or IF index. So we're making a distinction here. There's a probing interface, the guy who's sending the echo request. He's sending it to a proxy, and the echo request has in it, in its payload, something that identifies the probed interface. The proxy and the probed interfaces are different from one another. The proxy interface receives the extended echo request, determines the status of the probed interface, and returns an ICMP echo reply. And the echo reply reports the status of the probed interface. Now, this probed interface, it can reside on the same node as the proxy interface. So say the proxy is the loopback on a router, and the probed interface is any other interface on the router. It can also be directly connected to the node upon which the proxy interface resides. So let's say for a moment that you send your extended echo request to the loopback on a PE router. You can ask for the status of a CE interface that's directly connected to the PE router. No hands go up. Everybody's sleeping. That was the new thing.
I know.
Oh, man. Next time I'll have fireworks. Next slide. Okay. How do we determine the status of the probed interface? Well, if the probe interface is on the same node as the proxy interface, it's easy. You do exactly what you would do to determine the IF opera status in MIB2. If the probed interface is directly connected, if it's not local to the proxy interface, what you do is take a look in either your ARP table or your neighbor cache. If the address appears, then you say, oh, yep, that interface must be there. If the address doesn't appear, you assume that the interface does not exist, and you send that kind of response back. Next slide. So let's take a look at some of the differences between probe and ping. Probe tests two things. First, it tests bidirectional connectivity between the probing interface and the proxy. If you don't have that, probe won't get a reply. The next thing it tests is the status of the probed interface. If the probed interface is down, you get a reply, and the reply says the probed interface is down. If the probed interface is up, the reply says the probed interface is up. The other thing it gives you is, given bidirectional connectivity to any interface on a node, probe can query the status of any other interface on the node or any interface that's directly connected to the node. Next slide. Okay, we've talked about this mysterious new ICMP message. Here's a few details about it. Like any ICMP message, it has an IP header. The destination address is the proxy interface. You always send the packet to the proxy. In the ICMP body, the type is to be determined by IANA. There's a code, a checksum, an identifier, and a sequence number, and they're all the same as the traditional ICMP echo request. The only difference is that the sequence number is only 8 bits long, and that's to make room for an L flag. The L flag tells you whether the probed interface is local to the box or directly connected to the box. And it has an extension structure that identifies the probed interface. Next slide. Okay. The extension structure has 1 or 2 interface identification objects. They identify the probed interface either by name, address, or IF index. And if it does it by address, it can be any address type. So let's say for a minute you sent a ICMP v4 packet to a IPv4 only loopback address. You can be asking about a interface that is IPv6 only and identifying it by its IPv6 address. Maybe it's IPv6 link local address. Now, this link local thing brings up the kicker. You might have 2 interfaces with the same link local address on a box. So sometimes you need 2 interface identification objects to uniquely identify a probed interface. Next slide. The extended echo reply returns exactly 2 pieces of information: operational status and what protocols are active on the interface. It doesn't return anything else. This isn't meant to be an SNMP get on the all the attributes of the box. It just returns 2 things. It's a ping lookalike. Next slide. Okay, use cases. Why did we go through all this? Well, the use case I was thinking about when we started this is I wanted people to use more unnumbered interfaces. And the reason I wanted to do that was to reduce the attack surface of a router. Also wanted to make provisioning easier so you don't have to manage all these addresses. That was the driving one. But then more things came up. For instance, what if the what if the proxy and probed interfaces are different address types? One's IPv4, one's IPv6. Or what if you just don't have a route to the probed interface? You only have a route to the proxy. Okay, next slide. Okay, here's what this looks like. We have an implementation, and it looks strangely like ping. You know, the word is probe. Here we're querying by name, so it's minus interface and the name of an interface. And the 10.10.10.2 is the proxy address. And you get something back that looks like a ping. Next slide. Here another one. We're querying an interface by its link local address. Next slide. Okay, lots of security possibilities here, lots of security considerations. You can use probe to discover things about a box. For instance, you can use it to discover if you find that it has an interface called GE-0/0/0, you can infer a lot of things about that box, like who the vendor is, maybe what version of code it's running, maybe what the bandwidth or MTU of the interface is. So you may not want to open probe up to anybody. Next slide. So what are the mitigations? Well, for a node, by default, it doesn't honor ICMP extended echo requests. If it does honor them, the query types are enabled one at a time. By default, they're all disabled. So you would have to enable ICMP echo requests and only queries by address, not queries by name, if that's what you want. And further, for each type that you enable, you can specify which source addresses you will accept the query from. So that way you're sure that, you know, if you get a query, you know it's from your own NMS, or you know it's from inside your own network. You know, you can enforce whatever security policy you want. Next slide. Okay, the status. We've had many rounds of this, many comments, thanks to Jeff Haas, Somini, Jonathan Looney, Carlos Piñatero. We have a new feature, thanks to Med Bocader. Med, you didn't jump up when you heard your own feature. I'm heartbroken. And we have a working prototype, thanks to Reggie Thomas, which brings us to our next slide. I think we're probably ready for working group last call. What do other folks feel? But first, questions.
Comment on the IF name handling. One thing I was trying to look up and didn't have a chance to before you got there is that I'm inferring an answer based on the text of the document, which says that it can be UTF-8.
Yes.
By that, I'm inferring that it's not constrained to the ASCII character set.
Yes, in the text of the draft,
Yeah,
it does say
okay.
UTF-8.
Okay. So what that means is that your draft is currently under specified, and it does not guarantee interoperability, and it's easy to fix. So right now it says UTF-8, but it does not discuss normalization form. And so you need to do one of two things, or perhaps both. You need to either say that the sender has to normalize and put it in a particular normalization form like NFC, or you have to say that the receiver must accept anything and do normalization itself. Otherwise, the lack of interoperability happens if the sender just puts it in whatever its natural normalization form is. The sender does a byte-for-byte comparison against its internal representation, and they use different normalization forms, and you get a failure. And that's what can happen today, and you're conformant to the spec. So you gotta solve that problem and get interoperability.
Okay, in this area, I'm absolutely naive. If you could send me a quick paragraph, I'll put it in there.
Either of those two solutions work. You either say the client has to normalize, or the server has to normalize.
Okay.
Or in theory, you could do both for redundancy, but
Okay, I'll get with you offline and post that before the
Okay.
sun comes down
All
tonight.
right. The second part, which is a variation of the same thing, is you say if the IF name was longer than 255 octets, you truncate at 255 octets.
Yes.
The problem with that is when you truncate a UTF string at 255 octets, what you get is a non-UTF-8 string, because you can be truncating right in the middle of a character, and so you can't do that.
Ooh.
And so if you're going to truncate, you have to truncate on a character boundary, which is not at 255 octets. It's at 255 octets truncated 0 or to 2 more bytes in order to get to the character boundary.
Okay, I'll corner you offline, we'll craft text, and we'll have it posted by the end of the day. Any other questions?
Any other question?
So it goes back to the last slide and the ask for a working group last call?
We'll do that on the mailing list.
Okay, thank you.
Thank you. Hello. Yeah, here we go. No, actually, we don't have. You have to ask me. Sorry for that.
You have a point.
I am your point. Is that okay?
No, I've got to move it back. I think I'm going to. Later.
The laser? You have it?
No.
This one doesn't have it?
I don't know. It does. Okay.
Hi there. Right, I was here about a year ago. Well, not here, but in this working group. This is a draft that's being fast-tracked through TSVWG, intended to go to last call, working group last call in October now. So we want eyes on this because it actually updates INTAREA protocols. Next. So this is what the problem is. I've now labeled this problem number 1 because there's another problem. But the main one is that when you're tunneling IP headers, ECN is unlike any other field in that not only does it have to go down the layers as you encapsulate, and not only can it change once it's down the layers, but then you also have to propagate the change back up the layers, right? And there is no other field like that, as far as I know. And so at the egress, shown in that little table that's deliberately too small to read, is a matrix that's already in RFC 6040 of what the outer header is, what the inner header is, and how you calculate the forwarded header. Then the problem is, on the last bullet, main bullet of those three, if the decap, as shown, where's that one? If the decap here, shown in white, does not support that function, you must zero the ECN field before you put it into the tunnel, because otherwise, if you have just copy the ECN field, and there are ECN capable machines, network elements along here that mark it, those markings will not get propagated back up. They'll just get dropped on the floor when it decapsulates, and then all hell breaks loose. And all hell breaks loose means your load into the tunnel is potentially loading up a buffer. That buffer is growing, but rather than seeing drops, the congestion markings that are being generated by that are just being thrown on the floor, and so the load just keeps getting bigger until it overloads that buffer, and then the host will respond because they'll see the drops, and it will oscillate between short queue and long queue continually, and you'll get a very horrible network. So the problem with this is, and we only realized this recently, that we specified that tunnel behavior for nodes that want to comply with ECN. But the problem is this requirement is for nodes whether or not they comply with ECN. All tunnel nodes have to do this. This is not just if you want to comply with ECN. And so what we've had to do is make this a requirement for operators to configure it, not just for implementers, right? So we certainly want you guys to review this, and certainly any operators in the room to review whether that is feasible, because what it actually means is if you've got to be able to configure it to zero the ECN field, you would think that's quite easy, but it's not if your implementation still thinks that this ECN field, which is 2 bits, is actually part of the TOS byte, because that was what your grandfather told you when the internet was first built, and your implementer read it in some TCP/IP guide on the internet rather than looking at the latest RFCs, because ECN has been there now for 16 years, but people are still thinking it's a TOS byte with 8 bits in it. And so quite often you'll find, like, say, L2TP tunnels treat that as a TOS byte, and the configuration of the diffserv behavior can be configured, but it treats the 2 bits and the 6 bits as just 8 bits, and it can't treat them differently. So we've put a very strong requirement in there. Implementations must decouple ECN and diffserv code point configuration, because otherwise operators can't even do that. So there's, potentially big problem here. Not a problem at all if there's nothing inside the network that's that's actually marking ECN, but those sort of nodes are now appearing. We're starting to see that appear on the internet. If you look in the measurement MapRG group, they are starting to see it appear. And generally, your tunnel may not know what is inside the network that it's tunneling over. Okay? So, important. Now, what this draft was originally trying to solve was the problem that RFC 6040 that defines the behavior of tunnels and ECN, it wasn't potentially clear what the scope was. It said all IP in IP tunnels, and this update clarifies that that includes IP and IP with stuff in between, with shims, with layer 2 and shims, and so on. So this is the outers on the bottom here. I'm going to call this IP, shim, possibly layer 2, and possibly IP inside. But if you don't necessarily know whether IP is inside, if you're you don't want to have to look that deep. But if you don't know, you have to zero the outer IP in case there is an IP header inside. Right. So we had a look through and surveyed what standards track RFCs we've got that are like this, IP shim IP or IP shim layer 2 IP. And you guys have obviously been busy. This isn't all Interea's fault, but there clearly is a management problem here somewhere in that I'm sure we don't need all these protocols, right? To all do essentially the same thing. Obviously, there are differences. You know, that's a broad brush statement. But so what this table does, we've had to ignore anything that's not widely deployed or standards track. So anything with a cross there, where there'll be no other entry in the table. AOK means it specifies what to do with the ECN headers, and we're fine. I'll come on to what the exceptions mean. No K, not okay. There's two possibilities. One is that this draft, we have written update text into this draft, and the other is that it's not an IETF tunneling protocol. Maybe there's an IETF RFC, but we're not in control of it. So I want you guys to look, if we can just pop back to the last slide, Teredo, GRE, L2TP v3, the LTTP guys are reviewing that. The one that I've had no comments back on is GRE. Had no response to my emails on that, and it's obviously quite important. Next slide, because I've got a question on that. Or do you want to? Do you want to wait until the end, or?
Wait till the end.
Yeah. Okay. So a lot of work on this because we're fast tracking it. 4 revisions since the last cycle. Thanks to all those people there. I've said what the milestone is. I think we've agreed to last call it, David, with Interea, yeah? And I'll carry on talking while you come to the mic. The 3 questions I've got, in that table it says SFC is not applicable because they haven't defined an actual encapsulation. Is that true? And the second question is it true that there are no automated GRE tunnel setup protocols? Because I can't find any, but you guys should know whether there is, and no one in TSV knew this. And Teredo, I'm dealing with that with Praveen in Microsoft. So let's go for a question. Mike.
Tal Mizrahi, Marvell. So there was some discussion about this in the NVO3 mailing list, mainly regarding VXLAN and Geneva.
Yeah. And
correct me if I'm wrong, the way I understand it is that actually each RFC that defines an encapsulation over IP, an IP encapsulation will need to define, to have a section that says what happens in terms of ECN propagation, right? Yeah. And so my question is, would it be possible in this draft to define a small set of options, like for example, the way to propagate ECN is option 1, option 2, option 3, option 4, and then
that's already in the base spec. This just updates that to say this is basically this draft exists merely to put update text in for protocols that legacy protocols that all need to be updated to point to that spec and say what you have to specifically do for those legacy protocols like L2TP, GRE, things like that. In the original spec, there's 2 modes and exactly what you want. There's compatibility mode and normal mode. Right. And the compatibility mode is the zeroing the outer. And that's all you need to do.
So actually what you're expecting from Geneva is to define we're going to support option X from draft ECN shim?
Yeah.
Okay, great.
Yeah.
Thank you.
Yeah. It's easy. It's just I mean, for instance, in VXLAN, it's actually now in the Linux code, but it's not in the spec.
Srigandavelli, Cisco. On the second bullet point, so to your question, is there a protocol that sets up the GRE tunnels? If you look at it, mobile IPv4, mobile IPv6, proxy mobile IPv6, IETF, they're all control plane protocols that result in creation of a GRE tunnels. So
right. So, but do they sort of negotiate capabilities of the tunnel endpoints?
Absolutely, GRE keys and many other parameters are negotiated.
So they're the place where they need to say, one end needs to say, does the other end support ECN decapsulation so I can put ECN encapsulation in? Yeah. Right.
We have to look at all of these protocols, control protocols, see what we have. We have considerations on how to create GRE tunnels. Right. We have to look at those, look at the text and say how to, whether the text is, goes with, or further updates are needed.
Okay. Thanks.
So, David, if you're okay with this, I think it's no problem, last calling it here as well. So just
David Bracken, TSVWG chair. Yeah, we're going to last call this wherever it is. What I got up to say was that the earlier discussion about options, let's just double check that we've got all the right text on this and the options in the tunnels draft, because people aren't going to come looking for this ECN specific draft when they put in the next tunnel, but we hope they're going to go read the tunnels BCP, and so we need to make sure that I'm pretty sure Joe's got 60/40 text in there, but I think we need to go check that, make sure it's right, make sure it offers guidance to implementers and possibly operators about what has got to be done to not lose congestion indications.
Okay, thank you.
Ron Bonica, Juniper. Could you go back to the slide with the great big table? Oh, no,
the gray table.
That one. MPLS isn't in that list. Should it be?
No, because MPLS is already covered in the original draft. This is an update to cover all these other things. The RFC 5129 already does ECN and MPLS. Yeah. And just general IP and IP without a shim isn't in this table for the same reason.
Okay, thank you, Bob.
Thanks, Bob.
Thank you.
Okay, thanks. My name is Tal Mizrahi. I'm from Orville. And this draft defines guidelines for specifying packet timestamp formats. It's joint work with Joachim Fabini and with Al Morton. And actually, this draft is submitted to the INTAREA working group. It was also presented this week in TikTok and NTP. We'll talk a bit later on about which working group is the right place for it. Next, please. So in general, timestamps are pretty useful in the RFC series. They've been used in a lot of RFCs. We distinguish between two main types of timestamps: text-based timestamps and packet timestamps. So here's an example of a text-based timestamps for a netconf RPC in this case. And there's also an example of a packet timestamp. This is the NTP packet format. The main difference is that text-based timestamps are intended to be more user-friendly. They don't necessarily have a fixed length. And packet timestamps have a fixed length. They need to be compact. They need to fit into a packet header. Next, please. So like I said, text-based timestamps are used in a lot of RFCs, and their format is defined in RFC 9339. And these are a few examples. There are a lot of other examples of RFCs that use these text-based formats. Packet timestamps are also very widely used. This is, again, a short list of some of the RFCs that use it. Next, please. And there are also a lot of internet drafts that are currently in progress, which also use packet timestamps. Now, the main issues that we're trying to address here, first of all, there is no common timestamp format for the packet timestamp variant. That's one issue. And the second issue is that a lot of these drafts or RFCs define their own packet timestamp formats. Now the problem is that the way these formats are defined are sometimes very different from each other, and in many cases, the timestamp is defined in a somewhat unclear way or ambiguous. So these are the main problems we're trying to deal with. Next, please. So the goal of this draft, first of all, to define a relatively small set of recommended packet timestamp formats, and also to define guidelines of how to specify new packet timestamp formats. Next, please. So these are basically the recommended timestamp formats that we're currently presenting in the draft. So we have two formats which are based on NTP, a 64-bit format and a 32-bit format. And there's also a 64-bit format which is based on PTP. And the idea is that if you're going to use a timestamp in a network protocol that typically runs on a PC or on a server, you'll often want to integrate that with NTP. And then you often want to use an NTP-based format. And on the other hand, if you're going to implement a network protocol that typically runs on hardware, where sometimes PTP is used, it makes more sense to use a PTP-based timestamp format. Next, please. Okay, so we expect that in most cases, the timestamp formats we saw on the previous slide will fit most scenarios, most requirements. However, in some cases, we understand that people will have different requirements, will want to define a new timestamp format. So in these cases, these are recommended guidelines or actually a template of how to define a timestamp format. And the template consists, first of all, of specifying the field format, the number of bits, the units. If the timestamp consists of a few subfields, then we need for each of these subfields to define these properties. Then there's also the epoch, which means when the time starts, for example, 1st of January 1970. Any considerations related to wraparound, like when the timestamp is going to wrap around, and also any considerations related to synchronization, whether we expect the endpoints to be synchronized and to what level. Next, please. Another aspect that is discussed in this draft is an optional control field. So in a lot of cases, if you're using a packet timestamp, you will need some control information about that timestamp. So for example, that control information can include what the timestamp format is, what is the precision or resolution of the timestamp, what is the epoch, the era, and we're actually looking for feedback about what kind of control information you believe may be required in this aspect. Next, please. Okay, so this draft, the first version of this draft was submitted in the last month or so. We submitted it to the Internet Area Working Group. One of the things we were looking for is feedback about what is the correct working group to consider this draft. And the feedback we received from Suresh was that probably the best way or the best place to discuss this would be in TikTok and NTP. Also at this point, like I said, we're looking for any kind of feedback specifically about what kind of control information you believe should be included in the optional control field. And any comments would be appreciated. A special bonus to anyone who has counted the number of times I said timestamp in the last few minutes. Not everyone at once, please.
All right. In TCP/M, there's currently work on just starting on redefining the TCP timestamp, or at least agreeing on various timers at either end, and then you have to agree the clock granularity and things like that. So the units you've got there, are you using a standardized format for that, or are you having to invent a format for units? Because that's the big problem. It's what resolution is each end talking about?
Okay, that's a good question to consider. At this point, we just specified you need to say what the units are. One thing to think about would be to have kind of options you need to choose from.
Right.
Point to consider.
Yeah, because you know, a lot of the timestamps in the past were in sort of millisecond type granularity, and we're now needing sub-nanosecond, you know, and so you've got a, one problem is you need more bits because the wrap is greater because you've got more packets on the wire at any one time, but the other problem is what is the resolution that you're talking about at each end?
Right.
Yeah.
Thanks.
Bob, is there a draft for this?
Well, the latest one is Google's low latency TCP option, but there was one previously from Richard Scheffenegger, which has expired now. I'll put it on the list.
Okay, send me a note. Yeah, thanks. Good.
Gabriel Montenegro. So I did notice that you had on the list of existing work document out of 6LO working group. And I'm wondering if you're going to operate in a sort of like MIB doctor and B packet for, you know, timestamp doctor type thing. Because so I would like to ask you for review for that as working group co-chair of 6LO. It would be good to have your review on that document, on the 6LO document. It's already listed there, the 6LO, LIGO 6LO expiration time, whatever. So it's not, it's got elements of timestamp there, although the purpose is more expiration time, but I'm sure we would benefit from, you know, you guys looking at it. So, thank you.
Okay, thanks.
Okay, thank you, Todd.
Thanks.
Eric? Preferably not.
Bad USB.
Okay, good morning. So my name is Rick Vink, presenting the second ref of this draft. It has already been presented this week by Pierre at Sixman, because it has an impact on the IPv6 protocol, as well as by Tommy and the Captive Portal Working Group. I think it was yesterday. In short, what you are trying to solve is partly multi-homing for IPv6 and others. Nowadays networks, when you have a host, like the laptop which is here, it can of course be connected by multiple ways. You can have your phone doing tethering with the mobile data. You can be connected by Wi-Fi, by Ethernet, so two different interfaces, going to the same access network, which is itself connected to two networks, one being your normal ISP and one being your VPN provider back to home. So now, if you have an application there, which addresses and which interface do you use? Next slide. So basically, in the legacy world, which means, you know, the stuff called IPv4 with dotted addresses, you select one interface only, and you go. And you use NAT to ensure that the traffic is coming back through the same network. But typically, that's not what we want to do in v6. Next. In the case of multi-homing for v6, you will get provider-routable or provider-assigned addresses from all service providers. So in the case of the previous slide, you will get 3 prefixes, and you can select as many addresses among those 3 prefixes. And again, it's bare minimum 3. Some reference there. Now, the question is that all the application, all the hosts can select one or several, in the case of multi-path TCP, addresses, which is the next stop, which is the DNS resolver I'm using, and so on and so on. So that's basically the problem we are trying to solve here. Next. And interestingly enough, this issue has been raised multiple times this week. So I don't think Marcus is in the room, but he presented this, I think at V6 Ops. There's the Microsoft IT network using their own addresses. So you see, sorry, here, this is the prefix from Microsoft IT, but of course, Microsoft has got also cloud services, Azure, which is using from the same top global prefix. So now, if you have in the branch of Microsoft both connectivity through, I guess, some MPLS VPN or VPN, whatever, and connectivity to a local service provider, the host there will receive two prefixes, one from the Microsoft IT, one from the service provider. Source address selection in this case will work fine if you want to go to the internet, but if you want to go to the internet to reach any cloud services in Azure, guess what? You will select the address to go to the corporate network, and then you are into trouble. Nothing can be fixed really easily there. Next. Another one, and Ted, you are here. You presented this. When you have two interfaces, and also two interfaces you receive through array or DHCP or whatever, DNS resolvers addresses, you need to be sure that you are sending a request to a DNS resolver from the address associated to this interface. Else, you will receive a reply which is not correct. Think about geolocation, right? I'm connected to the VPN of my employer right now. He believes I'm in Amsterdam. And as far as I know, we are in Prague, right? So if I go there, ask an address to my VPN provider, I will be redirected to Akamai or Cloudflare in Amsterdam, not in Prague. There's a problem. Next. Another one, and Christian is here, I don't know whether Fernando is here. What about an application? As I'm a client, it's kind of easy. But if I am the listener, the server, if I do a bind and I want to listen to all addresses, but should I listen to all addresses or only part of the addresses? How can I select this? We need to expand there as well. Next. So in short, I wanted to prove you that there are use case, real problem. I mean, I was not aware that Ted and Christian and others will be presenting this week. So that's a real problem to be addressed. What we want to do is to follow the RFC 7556 for PVDs, make them identify, and once you get the ID of the PVD, try to get more information about this provisioning domain. Right? Not limited to addresses, next hop, and DNS information. Next. We focus on the current protocol, IPv6, and the way we design it to be very quick and efficient is to send this PVD ID option into a new router advertisement option. And we simply put there, we put some lifetime, but we put the fully qualified domain name. So something like, I don't know, pvd.ietf.org. Couple of flags. One which is important is the H, meaning that you can use HTTPS to get more information. The set of information into the array is limited, but you want to get more information, like pricing. Is there a captive portal? Is it a walled garden network, and so on and so on? Come back on this. And a L flag, which is mainly that you can bundle this V6 information with some IPv4 information you get through the HTTP v4. So how does it work? Next. The client on the left starts and you receive a route advertisement, including this option. If the client doesn't know this option, that's fair. It will get the array and will use it as usual. Now, if he knows the option, and if in the option there is the H standing for HTTP, it will simply go and to the specific URI where you use the PVD ID which is in the array, .wellknown/PVD, and get the information. Next. By this HTTPS connection. And we use HTTPS on purpose here. Next. The additional information which is fetched over this HTTPS connection is a JSON file, very extensible. You can put whatever you want. Some example there. Again, we can put information about walled garden. This is the no internet, whether it's free or not. Captive portals, you can go directly there without waiting to be redirected. Could be useful if you don't get a user behind the mobile network. And if you want to try on your own, there is one which is there, and it will stay there for a while. Next. Now, assuming that the host here, over a single interface, but could have 5 or 10 interfaces, receive multiple arrays, it will make bundles linked by this PVD ID. The bundles are the prefix, the route information, the next hop, the DNS search list, and the DNS server. Because then we solve that problems, right? We always go by an interface using this address to go to this DNS server. We make those bundles. There are this kind of Venn diagrams here, and it's up to the host, or more probably to the application, to select whether you use any of those, like the Firefox and Safari here, or you use only the red bundle, like Skype, or you use the green bundle, like VLC here. Next. Where are we? This is actually very easy to implement. Right? This is just another array option. You need to change the semantics into the stack, which is a little bit more complex. There are open source code. So Pierre and myself are working on this with another guy in Paris, where basically we work on Linux. So the Linux client receiver is there with patches. We have built a Wireshark dissector, so we can display all those options of the Wireshark. We modified IP route, we modified array DVD, and in this IETF hackathon over the weekend, a couple of us were there. We added the support in OpenWRT, already. Tommy added the support on iOS. As you can see already there, you don't display everything, but this is the normal iOS network selection. You see networks, and there are 3 networks. Meaning on one SSID, he was able to receive the 3 PVD and display them. That's what we did. And Tom Jones into the NEAT project, and Dory is there as well. I made some integration with the NEAT project, which is kind of a middleware at the transport layer. Next. And tonight, at the Bits and Bytes, please come and see us. Pierre and myself will be there. We can show you there how we make something working with the captive portal. Next. Okay, last slide. Next step for us, we receive very useful feedback during the hackathon. So Pierre is currently working on it to upload the -02. Minor things like using a well-known URL rather than something else. Now, we really, really welcome, and that's one of the reasons why I'm here in this room today. We really want to get feedback. Oh, so who read it, by the way? So something like 10 people. So all of you, please comment on the list, or now, Sri.
Yeah, Sri. So the question is, in MIF working group, we had a couple of the MPVD documents, right? One was NDP, one was DHCP. Those were working group documents. So I asked, what changed? They were killed, they didn't move forward, and suddenly we are, what's the disconnect here between the two?
I won't come back on the history, but this one only use array for good reason, because it's simple, right? And there is no blocking factor associated to it, to say it mildly.
That's too much of a detail, right? But the key thing is, at a very high level, those drafts tried to solve this problem. I think that's as a co-author, for at least 2 of those documents, right? We should either take those documents forward or somehow consolidate that work. That would be, I'm not objecting to this. I like this work because prefix coloring is something that I started. Actually, I introduced that term. Okay, so back 6-7 years back, there were slides on that. But I don't want the work to be wasted. But to be fair, that work needs to continue.
And Sri, you are more than welcome to join us on this.
It's not just me, but it has to be consolidated. That's all my point.
Okay, thank you.
So I definitely support this work. I'd like to see it go forward. It's
Ted,
obviously
we can
useful.
barely hear you.
Oh, sorry. So I definitely support this work. I think it should go forward. It's really useful. It's not complete in the sense that it doesn't solve all the problems that I think are problems. Were you in HomeNet when I made the presentation?
Yeah.
Okay, so you saw that. Yeah, so one of the things that this is missing that I think is actually important is a way for the host to signal that it supports it. Because in fact, if the network doesn't know that the host supports it, it really shouldn't be giving the host multiple prefixes, because if it does, the host will experience bad behavior. So the network needs to pick a prefix for the host if it doesn't support PVDs. I don't think that means that, I think that this can go forward independently of what I just said. I don't think that the two things are, that there's a cross requirement there, but I'd like to see work happen on that as well.
Which just makes sense. Thank you.
Lorenzo Coliti, to Sri's, partly in response to Sri. So there were a few things that went wrong with MIF. One of them, of course, being that the working group was shot in the head. I still don't know how that happened, because it basically happened overnight, and IETF, I wasn't there. It's like, okay, the working group has been closed. Have a nice day. All right, fine. But really, I think this is a continuation of that story. Another thing that I have to say against those drafts that came out of MIF is that they tried to do way too much with way too little OS vendor support, and that is not the case for these current efforts. I think we've got line of sight to actual implementers building this stuff. So, the running code part of it is way more true here than it was then. There was an IPR claim that we all stayed away from, which was sort of, I don't know if that was part of the reason why the working group was closed. And so there are a number of things wrong that we think we did learn from. And so these efforts are, in some sense, a continuation of those. They're a little bit de-scoped, but probably more realistic in terms of actual implementation. I see Dave nodding his head, so he's, I think we have, I forget who the authors are here. I know it doesn't include any of us, but I think Apple maybe is an author. Is that right? No?
It's basically, currently the authors are Polytechnique Paris, Apple, and Cisco. But
oh, there you are. Yeah.
We've been working on this as well, right? Yeah. Many other people are working on it.
I think Lorenzo, Sri's point was the previous work was not acknowledged, if I understand correctly.
I see.
Bernie Vols. I want to just follow up on Ted, that I think you do need to consider, either doing what Ted suggested or at least documenting what the impact is of sending these RAs with PVDs to devices that don't understand them. Right, that will just process them as normal RAs, or I forget, I think that's what would happen.
I mean, they will simply, we've done it, right? So come with your device tonight at the Bits and Bytes, Bernie, and you will be on one SSID sending 3 arrays with 3 different PVDs. It will ignore the PVD options and it will configure the 3 prefixes.
Right, okay.
But it's there, yeah, it's there.
Okay, I missed it, I guess.
There is a host behavior which defines it.
Hey, go to the RA slide.
Sorry, which one? RA slide?
Oh, too late? Or?
Yeah. Oh.
Back one. So, I think this is interesting work. The thing that I'm sort of wonder is, this is putting stuff in an RA that causes you to then look up a fully qualified domain name, if I'm reading that right, and open, and do a web browser thing to get some information.
No, not a web browser at all. It can be fully automated.
No, so you're going to a web server somewhere.
That's correct.
Right.
That's correct.
So this has got all kinds of failure. There's a whole bunch of dependencies in order for that to work. And I wonder if this approach might be very fragile.
Kind of true, but when you say the H, I don't remember the explicit wording we use into the draft. We say when you see the H, you should get back the additional information. The additional information is not really critical compared to routing or to addressing. But you're right. If we cannot get the additional information,
there's the IAB wrote a paper on, trying to have all kinds of dependencies which cause failures, and this has got a lot of them built into its design, so you might think about that.
Thanks, Bob. Thanks. And another thing, Bob, that I stated is that anything that does something with an RA gets 6-man review, so just in case you're wondering.
Eric Klein, if I could respond. one of the reasons to put it into the array is to bind all the minimum required amount of information, the addresses, the routes, and the DNS. But I didn't understand the problem then.
Well, let me take another take of Bob's problem statement. Christian Wiedemer. What you have there is a signal that says to the host, go to that website, connect to it, and go fetch a page. If you do that with a normal HTTP stack, you'll end up carrying cookies and all that kind of stuff.
No.
Well, you might. In any case, you get a signal that you have this connectivity. And having an outside connectivity like that, I mean, doing a call over the internet is not free. It has a privacy implication. Okay, so there is a very different privacy posture between go fetch information remotely, which means that you will have lots of traces all over the network, and finding in your DHCP server or something like that, which is local. So there are privacy implications on anything like that. It looks cool, it looks easy, but I really don't like the idea that a random router can force my host, unbeknownst to me, to connect to some external website.
Okay, so first, it's a may or should, I don't remember what we said in the draft. So you can, if you decide not to go to a website, this is up to the host. You go, you don't go.
It's in practice, it's not something that the user is going to decide on a connection by connection basis. It's either the feature is turned on or it's turned off. And I mean, I dare you explain that to your family that, hey, we have this new knob in the OS that lets you choose between multi-homing and privacy. I mean, it'd be better if this was more local.
Okay, but so, got the point here. But what's the difference if you receive into a normal array? Please use this DNS server as a recursive DNS server. You will also go to the internet, to this recursive server, resolver, and basically you will also invade your privacy, right? That's the same thing. I don't see sending a request over UDP for DNS and sending an HTTP request.
That is not actually true. I can configure my DNS software to always go to a trusted DNS resolver, whatever the network says.
Can you explain this to your family member?
Oh, yeah. You use private DNS, and that way you will not be snooped off by your ISP. That's very easy to explain.
Okay.
Tommy Pauly. So as the author, I mean, thank you for bringing up that point. I think it's good to consider, and we should probably clarify the stuff around that. A couple things. One, like, a lot of this is seen similar to what we already do with a captive portal. Today, I join a network. In general, the system on your behalf does an HTTP probe, and it's being redirected, and that's how you're getting all this information. You have no idea what's happening there. The goal with this is to try to improve that experience, that the resource you're fetching, ideally, in a lot of cases, would not actually be over the internet. It could just be locally hosted, and probably should be. And the idea is that at least this will be a secure connection rather than the completely clear text probe that your system's doing on your behalf pretty much any time it joins the network anyway.
Okay, Dave Thaler, Renzo and I got up at the same time, so I'm going to segue and let him cover the part that he was going to talk about. I was going to sort of rephrase what I think Bob's question is. Bob's question is not about the identification part, which I think is the part that Lorenzo is going to talk about, but how you get the sort of the bag of properties that you showed. And in order to get that, that means that you have to be able to do things like resolve the FQDN. You have to be able to route to the set of IP addresses that's there. And in order to correctly route to the set of IP addresses and to correctly resolve that, you might need to have that bag of information to make the correct decision. Which is a little bit of circular dependency, and that's where Bob was coming from. Now, that's the question. If you have a good answer to that, please answer it. But I think that's what Bob was worried about. Is it more or less? circular dependency, right? You can't get the information without already having the information to use in your decision-making process.
Well, and I mean, I'm agreeing with everyone who paraphrased me. But you know, for this to work the way it's written, and you got to make it so it does one thing, not make it all optional based on how something is configured. And well, it would be not deterministic. But my concern is this relies on all kinds of mechanisms to work correctly or not be subverted or for this. And if you should maybe think about some other ways of getting this information without relying on the DNS and the web and routing and
NTP and the CSP. Yeah.
I mean, so that's a lot of stuff to put in an RA, but it's not just that it's in an RA, it's that you're doing it at all that way.
Yeah, and as whoever was up here before Bob mentioned, it was the authors in MIF, right? They were saying, well, let's just put it all in the RA, right, which doesn't have the problem that we're talking about here, or let's just all put it in a DHCP v6 response or whatever else. It's just embedded all in one place. You don't have the extra dependencies. You just have, you know, whether it's size issues or whatever else. And so that's why you had 3 or 4 different ways debated as to how to do it. And this is another way, right? And so now we're beating up on the different problems with this one, and which is the same thing that happened to other proposals too. So.
Lorenzo Galudi, I think a couple of points. So Christian, I think you asked the wrong question, but it wasn't. It was close to the right question, and I think the question was not like why are you doing this? This has privacy implications. Because in reality, if I'm a router on the network and I want you to connect to me, I just spoof the DNS response for connectivitycheck.gstatic.com, captive.apple.com, and whatever it is that Microsoft uses, and you connect it to me. Okay, so you know that and let's move that aside. That said, we do need, and I don't think you do, a privacy section that explains how this is no worse than current operating systems today. Because I do believe that it's no worse, because those connections are going out as soon as we connect on very popular operating systems. So we do need to show, if we want to do this, that it is essentially no worse than we have today.
Which is the first statement, yeah.
Right. So we do have to do that. I don't think it's addressed, right? So that's very important.
It is no worse than we have today is a very weak argument. Okay. I'd like that the world in general goes to a better place. So let's continue doing something because we're already doing something bad.
The reasons we're doing something bad today are non-technical reasons that are not going to change. Yes, we'll have private DNS, I agree. And this is going to be authenticated, right? But those probes are still going to be there. And they're going to be there approximately forever. Right, so I don't. But yes, like I said, you asked almost the right question, and the question is like, why don't you have a privacy section? And that's I think the right question, because I think we do need to get this information. As for like being tracked, well, you know, once you can track those HTTP requests, even if in some magic future world where captive portals don't exist, we stop doing those HTTP requests. You can still track that someone's on the network by looking at their packets, right? It's really like they're there. You know they're there, right? So, and to respond to Bob, I think the PVD ID gives you 2 things, Bob. It gives you, first of all, it gives you an anchor where you can say, look, this thing exists, and if you receive other information. Maybe there's another router on the link that is in the same PVD. Maybe you have existing configuration about that PVD, like a mobile network name, like, you know, the Verizon network has this host name. Maybe you have some pre-existing configuration, a VPN client or something, and you attach those with that ID, and you have a secure way of authenticating them, so you can merge them. And the other thing that it gives you is, yes, the ability to use that ID to fetch things. The nice thing about putting it here is that the RA gives you atomically, and that's very important, it atomically gives you all the bootstrapping information that you need to make this request. It gives you an IP address, it gives you a DNS server, and it gives you this name that is that you can optionally use. Even if you use the ID to merge things, you don't have to fetch the metadata. The metadata is there if you want more information about what the network provides, such as, is this network metered? Or, you know, does this network provide access? Is it a captive portal? Things like that. So it serves these two things. I don't know if this is explicit in the draft, but it has those two roles.
Yeah.
Christian Wiedemer again. Obviously, we need some privacy consideration, but I'd like to basically make sure that we also have some privacy mitigations. Okay. That being said, there is another issue. Okay. What prevents the coffee shop from pretending they are Verizon?
Pretending they what?
What prevents the coffee shop router from pretending that they are Verizon or something?
So, and this is one reason why we put the PVD ID there, and we say HTTPS. So you need to be able to serve a certificate with your PVD ID.
No, that is true. That I get. I get that.
Yeah.
Okay, that if I go to an HTTPS connection to PVD ID, I know that I'm being served the exact information associated with PVD ID. How do I know that the router is claiming the PVD ID that they actually are?
Okay, so to make a long story short, right, because it's in the draft in the security section. So in the additional information, there is the list of prefixes of the routers that can advertise its PVD ID. So if you are a coffee shop somewhere in Prague and you pretend to be Starbucks in US, okay, you will of course go Starbucks US. You download the TLS, you get the JSON, you get the router should be this and this and this address. Oh, it's not. Bingo, you refuse it or whatever.
Yeah,
and there are additional techniques as well.
Yeah, and if but then you have the chain of dependency issue and all that kind
of course, I mean, security is not an easy thing, right? Yeah, of course. I mean, that's the goal of presenting here, so comment.
So, Bob Hinden again. I'm not sure, I may be misinterpreting what you said, but as we've learned recently, HTTPS does not mean that who you're talking to is who you think you're talking to. It means that you get a secure channel to it. We saw this thing with the free certs that bad people can get them too. And so I don't think just because it's HTTPS that it ensures that you're talking to who you think you are.
Okay, we need to talk on this, Bob.
Tommy Pauly, Apple again. I just want to tack on to the emphasis that we should look at the kind of the step one and the step two separately, that the primary goal of the step one is to say that when I'm in a situation in which I'm getting these multiple sets of RAs and information to begin with, and I have this plurality of information that's provisioning, I have multiple prefixes, I have multiple DNS configs, to say that, yes, the network knows what it's doing, and that at least within this scope of my access, that these are two different things that are consciously two different things that I can use separately. And that is the only thing you really have guaranteed. The secondary step of getting more information, I believe, and we should probably specify this more, is like all really nice to have things that you should be not making security decisions based on those. They are things such as saying, oh yeah, the network is claiming to be a captive portal, is claiming to be a walled garden, is claiming to have these properties as hints to the end host to say that to make user experiences better, we can kind of bootstrap processes that would otherwise be based on random redirection, random probes, and very non-deterministic. But it is not a reason to say that, oh yes, on this network, this person claimed that they are Verizon, therefore I'll send all of my, the traffic I would send potentially unencrypted on a cellular link directly to them. No, it should not have security implications like that.
Ted Lemon. So actually, to speak briefly to that point, there are security implications to this in the sense, and I imagine, I haven't actually read the draft, so I imagine you've already addressed these, but just to bring them up to the mic, that if you're able to say, my service is free, or my service is really fast, then you can't actually convince the host to route through you when your service actually isn't free, and thereby deplete like bandwidth or something like that's being paid for by lying. So there is that opportunity to lie, and I assume that you've addressed that. But yeah, well, it's the I am not evil bit, right? No. Yeah. So that's a bit of a concern, and I'm not quite sure how to address that. The other thing that there's two other points that I wanted to make. One is that in terms of ops, in terms of operations and dependencies, if you actually want your network to work, you have to make this work. Like, it has to be possible to reach the HTTPS server without knowing the PVD stuff, because otherwise it's just not going to work. So if you set up your network so that you have to already know what's in the thing that you're going to fetch with HTTP before you can fetch it, then it's just not going to work, and that's fine. You just learned a valuable lesson. And the actual point that I wanted to make is that one of the things that we talked about in MIF, which I think was actually kind of important, is that it's because we have to deal with the case of with the use case of hosts that don't support multiple PVDs, which may or may not be most hosts. I don't know. Mm-hmm. Since we have to support that use case, what we had talked about doing in MIF was actually wrapping the prefixes that are not the default prefix in the option, so that a host that doesn't know about the option will fail to parse it, and then they just won't see those prefixes. So actually, you would have just a general array. The host wouldn't actually have to identify itself to the network as supporting or not supporting this. It would just see the array. It would see the stuff in the array, and it would. So, is that something that you guys considered?
We considered at some point of time, and we reject it, but I don't remember the reason why we put it on the site.
So the one objection that I see to this is that you actually want one of these on every prefix, right? So you have to be able to wrap this inside of the prefix to indicate that this prefix has this PVD ID. And you also need it to be outside of the prefix. And so I could see where that could have been an objection. But I think that that's an easy thing to solve. You just have to set it up so that it either can or it can contain sub-options, but doesn't have to. And then if it's for the main prefix, you just wrap it in the prefix. And for prefixes that you don't want non-PVD supporting hosts to see, you wrap the prefix in it. So,
which is a good, I understand the reasoning. But I think Pierre went in the queue, so he maybe knows why we rejected at some point of time.
Just a small element of answer why that option was removed at some point. I think it's because one of the reasons why MIF was killed, trying to do too much stuff. So I have no issue with such a solution. It's just like we would like to aim for a simple solution first, not try to do everything. And if your use case require your host to support PVD and you want to support non-PVD aware hosts as well, maybe you cannot use this solution yet, but for some other use case, this solution will work. And for the future, we could decide to have another container option for arrays, which would do what you want. But put everything in the single document, it's not useful. It's just going to make it more complicated.
So Ted Lemon again. So I don't think that's actually a good reasoning. I think actually that the ability to say this is a PVD that MPVD aware hosts can use versus this isn't is actually probably the most important thing when you're talking about PVDs. And so as far as, I don't think, maybe there's some criminology going on about what happened with the MIF working group. I think the answer to that is probably less complicated than we imagine and is not what Pierre just said. So I think that we should actually ask for what we want, and if there's a reason why that isn't the right thing, then the consensus process will deal with it. And I'm just putting in a plug for what I want out of this option, in addition to what you've already done, is what I just said. And I think that it's eminently doable and very easy to specify. I don't know. Anyway.
To come back on the Pierre's argument, we wanted something very simple, right? They keep it stupid simple. This was the baseline of the document. But anyway, we can open, right? So.
Dave Thaler, I just wanted to comment on the intersection between two people's comments and elaborate on that. So I'm going to go back. Part of Lorenzo and others' comments were about how actually resolving the information is optional, right? You don't have to do it if you just can use the basic information that's in the array or whatever, right? Then you're just using it as an identifier. You're not using it as sort of a lookup mechanism. And the other comment was, Eric, when you were responding to the comments about security, well, how do I know that this router is the one that's actually authorized to have this PVD ID? And you said, well, you resolve it. And we said, well, but resolving is optional, and therefore security or actually trusting it is completely optional, and that's why the vulnerability or whatever that Christian was wondering about would exist. Now, there's a couple things you could elaborate on if you chose to in the security considerations section that says, well, if you've seen this PVID before, but maybe not from this router, and you've resolved it, and then you know which router or which prefixes might be allowed to do that, you can cache that, so not have to resolve it every time you might be operating off of a cached copy. That's the sort of thing that's better than nothing. But there is this sort of issue to talk about there, which is, do I need to resolve it to know whether I can trust it or not? Am I required to do that? Is security optional? Is security mandatory? And so there's a discussion there, but the notion of caching previous answers is actually something that will help.
Yeah, thanks for the caching information.
Not to belabor the point, but just checking the source address of the HTTP request at the server, I mean, it's so easy to defeat. It's not even funny. Yeah, no. But if the client
certifying the name that you were given.
No, I get that. But what you are saying is that the France Telecom server, for example, will only serve you if you are coming from a France Telecom IP address. I mean, the bad guys can go through that really easily.
And there is one thing, we cannot really aim, I do agree. I mean, if we could get a solution which is 100% secure, we would go for it, but we know we'll never reach this. So if we can get at least to prevent misconfiguration or very naive attack, that's better than nothing. Right now, anybody can send you arrays and they are little protection, right? Because if you do NPT behind, you don't see it or whatever.
I am very skeptical.
Okay, let's look maybe on mailing list or whatever.
Tommy, I think to the point of the addresses you're validating, it's the prefixes that the router has, not the other way around.
Currently in the JSON that you are downloading is additional information. You have the list of prefixes that are your PIO that you can accept.
Right. So I think slightly different from what you're saying. But I mean, back to Dave's point, for kind of like the bootstrapping of the trust, if all you have is the PVD information you get in the RA or the other direct options, and this is just an identifier, at that point, you should not be making any other assumptions about how that identifier is connected to anything else that you've known previously. The only things you would be possibly trying to protect the validity of are the things which are already in that extra information dictionary that you fetch. So there's not really kind of a problem of saying, so yes, if they claim they're Verizon, whatever, that doesn't really mean anything. It's just saying that on this link, this is one consistent set versus this other consistent set of information. So you should not make any other assumptions based on that until you've already fetched it. So there's not the bootstrapping problem because you only care about resolving once you have resolved and you want to say, what do I think about this other information?
Pierre Pister, trying to give another element of answer to Christian. It looks to me that what you're looking for is a way to trust your router about what it's telling you. And that's a quite ambitious problem to solve. Like, unfortunately, with arrays and DHCP, they are not secured, so it's complicated. Maybe what Dave said earlier is right, and HTTPS in that example is not a way to make sure that your PVD is what the server tells you it is. Just a way to retrieve the PVD without possibility of man-in-the-middle attack in the modification of the PVD object. But I think in our case, yes, you have to trust your router and the information that it gives you, you have to trust it as well. If you don't want to trust it, well, it's optional. You don't need to use it. You don't need to fetch it.
David Skenazy, Apple, also touching on the security and privacy implications. I think that conceptually this is similar to an RA in that all it is an advisory. In the same way, your RA could give you any DNS server, and as you were saying, you're free to configure your own. Your OS may want to do that, maybe always, maybe sometimes. You're free to absolutely do that. What this tells you is, if you want to know a little bit more advisory information, here's how you get it. And this HTTP query doesn't mean it's across the internet. Your HTTPS server could be like on the router itself or right behind it. And the idea is, well, you just told me what my prefix was, what my DNS was, what my extra routes were in the RA. Here are a few other related information from there. And also I can guarantee that I am in terminal2.pragueairport.cz if they source it from there, for example. And that's all I know. Like, it's just a string. It doesn't mean, oh, this is my corporate network. Let me send all my data in the clear now. You don't use it for that.
Lorenzo Calivi, another thing, of course, that is certainly an option is to rely on given that this is partly targeted at devices that might also have multiple interfaces, you can always use another interface to validate this PVD if it's on the internet, right? You have that option if you choose to do that. And that might be...
The normal behavior, indeed, Lorenzo, is to use the PVD information to verify, but nothing prevents an exception, though.
Right, but you don't have to trust it either, right? So the address check would be checking. You can do the address check on the IP address that you got, right? It doesn't have to refuse to serve you. It can just tell you. I mean, the thought was that it would just tell you these are the PIOs that you can have. I think that was what the thought was.
That's the point, yeah.
Right, and then you would check that. But my point is, if something is, you can have a model where you could choose to do that. I don't know if that's even written there at all. But in theory, you could use a different network to check whether that network was giving you something that can only be verified elsewhere, right?
Yeah, you can, for instance, use the VPN PVD through your trusted employer website. Anyway, definitely we need to get a privacy section. That's for sure.
I guess it might be a useful feature to add to this. You know, maybe if it's not the main way of doing this, I think we could explore that.
That's correct. More work for the authors. So by the way, it looks like we have a huge interest and very good feedback. Thanks again for spotting some room for improvement. My ask here, we want to get this work done. Implementation, working code is already there. So can we get this as a working group document to advance? I mean, there are related works that depends on it as well later, like Captive Portal or others. So what do we do? Or do we create a working group for this?
So, Eddie had, right? So, the INTAREA started to do like one-off items, right? Like, and I do see like a body of work associated with this that's going to happen. And either way, like whichever way you're going to go, we're going to get like review from Sixman, like and DHC, and probably like for the Ike stuff, like from IPsec.me, right? So I would really say like, you know, shooting for a like BOF would be like the best thing to do, like a working group would be the best thing to do. But it's really your call. So if you want to like, you know, request adoption, we can do that. Like Wasim and Juan Carlos can sit down and like do an adoption call to figure stuff out. But I think like last time Ted did something like this. It started off in INTAREA and then went off to MIF, right? Like, so I remember you presented like something about PVD and then it like started work in MIF, right?
I didn't charter MIF. MIF was chartered.
I understand, but you did a presentation about PVDs in INTAREA and then went down to MIF to continue the work there.
I did. I took DHCP routing out of the charter. Sorry, that's a digression. But essentially, the reason why I came up to the mic is that this work has been something that the IETF has tried to do for quite a number of years. The MIF working group was killed off. I don't think that the MIF working group was killed off for any particularly bad reason, but nevertheless, it was killed off. And that's where the work was happening. And that would have been the working group where this work ought to have been done. Since the MIF working group doesn't exist, yes, we could have a BOF at the next IETF, and we could, some number of IETFs later, charter a working group, and then that working group could start working on this work. That would be a really bad delay for no reason that I can think of. So I would really like to discourage that route. If what you think ought to happen, and again, this is speaking to you wearing your AD hat, if you think what ought to happen is that a working group ought to do this, then I would request that the IASG immediately charter a one-off working group to handle this work. And you know, we can sit down and write out a charter and do the IETF consensus process to make sure that the working group is approved. But I really don't want to see this wait for like 3 or 4 IETFs just to get to the point where it becomes adopted as a working group document. My personal preference would be to just adopt it here and get the work done. But if that's not okay, then I think we need a working group sooner than next IETF.
So I did have a chat with the proponents like yesterday, right? And with the proponents, like the people who wrote the draft and people who are interested.
Sorry.
So I didn't say like, you know, we need to do like a BOF to do the working group, right? But the point is there is different pieces in this document that need to go to different places.
Oh yeah.
Okay, like, okay. So if it's getting done in INTAREA, like as I said before, right, INTAREA is like not chartered to do like, you know, big things, right? It's like one-off things. And the question is whether we think this is a one-off thing to do. And if people believe that's the right thing to do, we can take it up in INTAREA and get it done and move on, right? And if not, we need to do something more. So that's something I would like the working group to determine, not me, right? But if we decide this is like a one-off thing, get it done, and no follow-up work, I'm fine with it.
I mean, if you want to recharter the MIF working group, I would be 100% behind that.
It's not my group, right? Like, but I can talk to Terry and see if he wants to do it, right?
You're an INT-AD, it can be your group.
I understand, right? Like, so, but we need to figure out like what has changed since Terry closed MIF, right? To do the stuff. So it's.
Well, I don't know. I don't actually know why Terry closed MIF. I have theories, and I don't see any point in speculating about it.
Yeah, nobody knows actually. So.
But the point is that you know, I think all things being equal, yeah, it really ought to be its own working group. But I don't want us to wait until that happens to do this work. That's what I'm getting at.
Right. So,
and I think, you know, there's the cross-area review stuff can happen whether this is done in INTAREA or whether it's done in some new working group.
Okay, thanks. Mark.
Hi, Mark Townsley. I agree with a large part of what Ted said. When MIF was, you know, quickly closed, if I recall, there was a message from Terry that said, and any remaining items that need to be moved forward, I will, you know, AD shepherd independently. And I see this as that work that did continue. I remember meetings that happened amongst the authors and other people after the IETF where it was MIF no longer existed, where we, you know, got together and, you know, started working on what you see here, right? With full expectation that, yeah, if we did a good job and we shopped it around to all the different working groups where it affects, where there might be an effect, et cetera, we had a path to AD shepherd and get this done in short order. I would like that promise to be kept. It doesn't have to be by, it's by the internet area. It doesn't necessarily, I don't think anything procedurally says that it needs to be Terry. It could be you. In fact, some other AD could shepherd it. But I would like to see that promise kept so that we can get this work done quickly. If you feel like you need a really short-term working group in order to put some chairs in because you can't scale and you need to have it, you need to have a chair there to help manage it, cool. But creating, you know, BOF plus working group, and which would necessarily end up like
opening up all those wounds and like, I was there and I did it too and it's already been done, why don't you do it that way, would all just happen again. And I'm not sure that helps anybody. To Lorenzo's point, we've got line of sight of code getting written in the right platforms. Let's not lose that. Thanks.
So Mark, why do you think it won't happen here?
Oh, here?
Yeah.
In INTAREA?
No. Why do you think all those like things you said, the bad things, right? Like wounds opening up, like people doing stuff. Like, why do you think it won't happen here?
Anything can happen. Okay. I'm not going to sit here and say what will and won't happen, whatever. But I just know I've seen the work that's been going on, and I would rather the people doing the work continue working on internet drafts, coming to hackathons, going around to the working group meetings, making sure everybody's on board, than dealing with, any sort of, entity creation and destruction in IETF context.
Okay.
That's it.
Shri Gundavelli, I think a couple of points. I think this work should move forward quickly. I think if we spend too much of time creating bobs and all of that, that's not going to help. I strongly believe it has a strong relation to some of the 5G work, like slicing. So in that sense, there's a urgency here. I think it should move forward on a fast track. That's my one comment. Second comment on the MIF is, I completely disagree that this, I think, wounds and all of that, yes, I feel that, I also did some part of that, but one comment is it doesn't belong to MIF either, because we did the initial publications were in DHC working group. We just called it class, somebody didn't like the name, they came out with some structural semantical changes and say it's something new. It's not. The core ideas were introduced much before that. So in that sense, MIF is not an owner, just that it was structured work. That's the only thing. But so, we should close that history or whatever, forget it, but we should, take up this work in this group and take it forward. That's my view.
Okay. Actually, Gauri.
So Gauri Fairhurst, we have vendor code, we have hackathon open source code, we have interest in a draft that's been talked about in multiple working groups, and there are probably other working groups like TAPS and the Path-Aware Networking research groups that could all build on this. I think there's a huge momentum here. That sort of momentum would normally create a working group. If we don't need a working group, then let's just adopt the draft. If we need a working group, then let's adopt the draft somewhere so it becomes an official item to focus the energy, and then figure out the working group afterwards.
Okay.
That's my take.
Okay.
Okay.
Bob?
Bob Hinden, I'll only add the observation that it seems like there was a pretty good, robust discussion about this here. So I think that's a good sign for thinking about doing it here.
Okay. What's your preference, Eric?
My preference, like most of the author, get it as soon as possible, adopt it somewhere so we can get a real document there. And then we need indeed, there are multiple, could be the foundation of more work, so where we can get a working group there. But honestly, don't wait, right? And for us, beside the privacy thing that we overlook, to be honest, we can finish a document, and then on we go. Again, the code is there, right? So, like Gary said, so.
Okay.
Mark.
Totally agree with what Eric just said. Let's not forget, though, sometimes we do, I think, an AD Shepherd document doesn't need a working group, okay? There's no procedural reason. You have the power. You can take a document and put it straight on the standards track in front of the IASG. Now, again, it's up to you in terms of whether or not you need the hierarchy, in the group to help you do that. But if you feel like you have sufficient understanding of what's going on here, and that you've seen, because all the authors are running around to all their different working groups and making sure they know about it, that distributed approach with you watching very carefully might be all that's needed.
Right. And the way I think about it, Mark, right? Like whether it happens in INTAREA or if I do AD Shepherd, I follow the exact same process, right?
Yeah.
If it's in some other group, right, like there is a difference, right? So if it's a 6-man document and AD Shepherd, like I go to INTAREA and like the relevant groups, but if it's in INTAREA, I don't see a difference in the process at all. So
okay,
I don't mind things either way, right? Like so, How many people have read this draft? Other than the authors? Okay, so decent number. So do you want to do a hum?
Yeah.
Okay, go.
Okay. So if you think that we should adopt this draft as a working group item, please hum now. And if you think it should go to another working group or even a new one, please hum now.
Okay, so the yeas have it. So confirm on the mailing list.
Yeah.
Okay.
Thank you. Okay, next presentation is Gabor in the room or? Okay. You need a pointer? No, I'll change the slide.
Hello, everyone. My name is Marius Georgescu. I'm with RCS Romania, and I'm also the co-author of the draft name MPT, Network Layer Multipath Library. And this is what I'm going to talk to you about today. So next slide, please. So what is MPT? MPT is a network layer multipath solution, which provides a tunnel over multiple paths using the GRE in UDP encapsulation, or RFC 8086. And by extension is also different from both MPTCP and Huawei's GRE tunnel bonding protocol. What are the benefits of MPT? So the most important, as with the others, the path throughput capacity aggregation, resilience to network failures, and our contention is it better suits real-time traffic than MPTCP. Next slide, please. Well, aside from that, MPT can also be used as a router, so routing packets among several networks between the tunnel endpoints, and also as an IPv6 transition technology, because the tunnel IP version can be different than the path IP version. Next slide. So how does the stack look like? So we have a tunnel interface that's going to handle the application TCP UDP headers and IP headers. They're going to be encapsulated in GRE and UDP, and then along multiple paths, they use UDP and IP. Next slide, please. So as I was saying, conceptually, MPT implements a tunnel over several paths. The tunnel packets can be mapped in different ways. So one of the mappings, and this one we have an implementation of, so per packet-based mapping. It can also be flow-based mapping or the combination of the two. So a packet would look something like that. We'll have the application data, tunnel TCP IP, TCP UDP, tunnel IP v4 or v6, GRE and UDP, and then the path headers, which will use port. Okay, so the port 4754 and then the IP version of the path. Okay, next slide, please. Of course, we'll have some connection specifications, which can contain several paths, and we'll have some parameters for that. So, for example, some tunnel attributes like name, permissions, tunnel IP version, etc., and number of paths. For the path attributes, number of paths, definitions, weights, and so on. Next slide, please. So in terms of control plane, the MPT servers are started automatically using configuration files. Of course, connection may be also later be established and turned down dynamically. The paths can be added or deleted, and we also have a keep alive mechanism there. Next slide. So this was a quite big diagram, so we split it into 2 slides. So if a tunnel interface will send the packet, we'll have checking connection specification. Next slide, please. And then we'll have the path selection and the encapsulation. And of course, we'll transmit the data to the physical interface. From the physical interface, the data is checked. Can we go back to the previous slide, please? And then because of different delays in packet arrival, we'll have packet reordering. And then the packets are forwarded to the tunnel interface back. So, okay. So the per packet-based mapping, as I was saying, was already implemented. So for each packet, a mapping decision is made. And since we have weights, we use them for load balancing. And the number of PDUs or bytes sent to a path is proportional to the weight of the path. And for this, we have a precise algorithm which we described in the draft. And also there's a sample C code. Okay, so this wasn't implemented. This is something that we're planning. So flows are identified by the usual 5-tuple. And then all the packets of a given flow are handled the same way. So the rationale is provide different QoS for different traffic classes, and we have some samples scenario described. Unfortunately, no implementation yet for that. Okay, next slide. Okay, since, as I was saying earlier, packets may arrive because of different delays at different times, we have to do packet reordering. So we came up with the order write delivery, and it's based on the GRE sequence numbers. It's done at the receiver. It has to import the parameters, the reorder window, so the size of the reordering buffer, and also maximum buffer delay. It's working well. It's been tested, and we are still kind of we have still these open questions like how big should be the reorder window, and like what's the optimal maximum buffer delay. So these are still being decided. Okay, next slide, please. So there are a couple of academic papers that were written on this subject. If you're interested in this, please go ahead and read them. Some of them are not open access, so if you're interested in reading them, please contact us somehow. So yeah, we tested the path throughput capacity, and we compared it to MPTCP, and we discovered that over 8 flows, which was the maximum that MPTCP supported, we have different, or we have better performance. Also tested fast connection recovery and elimination of the stalling events for YouTube video playback. Okay, so next slide, please. If you're interested in this draft, please support it. So in the academic community, it has already been presented. We would like you to find a home here in the IETF as well. So yeah, that's all from me. The floor is open for questions. Thank you.
Hi, David Skenazy, Apple. Thanks for the presentation. I didn't quite get the motivation. What are you trying to solve exactly?
We're trying to bring a protocol that better suits essentially live traffic, or it's a good alternative to MPTCP.
No. But either, like, that's not a problem. Like, why are you trying to use multiple interfaces?
Well, to have interface throughput aggregation. That's why MPTCP.
Okay, so what you're trying to accomplish is that if I'm downloading, say, or streaming a video, for example, I want more throughput. Is that the problem you're trying to solve?
Essentially, if you have, like, one use case could be like 2 enterprise sites that need a lot of throughput together. You want to maximize the throughput of each machine. You want to use all the interfaces. That's exactly what we're trying to achieve here.
So are you seeing this more as a kind of for like end device host, let's say smartphones, or are you thinking more like for data center to data center?
Probably data center to data center sounds more like a better use case.
Okay, thank you.
Okay, thank you.
Hi, David Allen, Ericsson. Seeing as you use GRE tunneling to establish your aggregate, and then you do per packet striping across these, which is exactly what the WOWI informational draft does, could you sort of go a little further into what you actually think the differences are?
Yes, I'm sorry, I didn't hear what exactly were you referring to?
Well, there's the WOWI draft that also uses GRE between a pair of proxies in the network to do per packet load distribution across the set of paths and the connection, to use your terminology. So how are you different?
So essentially, the per flow mapping probably will, once implemented, can establish that difference. So in this case, per packet.
Yeah. Well, I mean,
was
per packet only really makes sense where you have so few flows that you're not going to get good distribution. So I'm not sure your use case for per packet. And if you are doing per packet, then I'm trying to understand how this is different than stuff that's already documented and deployed.
Can you clarify what exactly is documented and deployed? Because I didn't understand.
I was referring to the WOWI draft, I think the RFC 8157 you referred to.
8157, okay. We'll take a look at that, thank you.
Well, it was in your presentation, that's why I'm asking.
Yeah.
So, Gori Fairhurst, when we did GRE and UDP, it was one of many different ways of doing this. Is there a need for an interoperable protocol to configure this? Are other people asking for this? Or is it a single vendor?
Well, for now, it's just a research project, which was, well, also has some running code. We would hope to have it developed here and maybe vendors to implement it.
Sounds interesting. And second thing is, how do you think this relates to Banana and the discussions that went on about the different ways to combine multiple interfaces, tunnels, or whatever?
Sorry, I'll have to get back to you on that question.
Oh, sure. Thank you.
Mark Townsley again. Thank you for the experimental results and the papers, and I wish you luck publishing more experimental results and papers. That's all very good stuff for us all to be able to read. You know, there's 100 different ways to tunnel. You've picked one. There's 100 different ways to decide how to put packets into that tunnel for whatever use case that you have, and you reach into transport area for sure when you start doing that. It's really fun to see the resurgence of B channels virtualized and bonding all over again. If we want to use IETF standards track documents, grab multi-link PPP, throw it over an L2TP tunnel, and you're done. You know, it's given, you know, now that was all, you know, created in a day where the links that you're bonding over or balancing over or what have you might have been a bit more similar than the, say, use case of 4G and crappy DSL asymmetric kind of bonding. But this is mostly a problem of deciding, you know, how the packets go into the two tunnels and come out of the two tunnels. You could use any number of tunneling encapsulations. And like I said, we've already got standards track RFCs for this. So please continue your research. Please keep publishing. I don't think we need another standards track anything for this.
Okay, thank you.
Okay, thank you.
Thank you.
Next item is SOC V6. Is Vladimir in the room? Yeah.
So hi, I'm Vlad, and I'm going to talk about SOX version 6. So the motivation behind this is that SOX 5 is 20 years old and kind of needs a facelift. It makes very liberal use of round trips. So it first takes a data round trip to negotiate the authentication method that the client and the proxy are going to use. And then it takes one round trip or more to authenticate the client. And then the client asks the server to establish a connection on its behalf. After the publication of SOX 5, people have come up with ways to do zero RTT authentication. So if two entities had previously communicated, they can authenticate in 0 RTTs on further connection attempts. Now we have a hot new use case for SOCs. Mobile devices are equipped with a cellular interface and also Wi-Fi interface. In case we want to use both of these interfaces for improved throughput, we have to use something like MPTCP. Now, since servers typically don't deploy MPTCP, network operators have to deploy some kind of proxy in order to terminate the MPTCP connection and open a vanilla TCP connection to the server. Now, since mobile networks typically have high latency, we have made some efforts toward shaving off as many RTTs off of SOCs as possible. So next slide, please. So in order to do that, a SOC 6 client optimistically sends as much information as possible up front without waiting to authenticate with a proxy. So it advertises its known authentication methods, the address of the server that it wants to connect to, and also supplies some application data upfront. It also can specify whether it wants the proxy to attempt to establish a connection to the server using TFO or not. Further, SOC 6 is extensible. All control messages have TCP-like options, and we plan to implement zero-RTT authentication via said options. So next slide. Now this is what SOC 5 looks SOC 6 looks when compared to SOC 5. So in SOC 5 we've got the method, the negotiation, the authentication, then the request, and finally the data can pass through. So we've taken the blue bit, the methods, the green bit, part where the client specifies what server it wants to connect to, and the red bit, the initial bit of data, and we've tried to place them in the initial data exchange, which would hopefully fit into one packet. So SOC 6, SOC 6 client sends a request in which it advertises the methods, its known authentication methods. It asks the server to initiate a connection, and it also provides some data. The server then replies with an authentication reply, which specifies what kind of authentication method must proceed. And after the authentication has concluded, the proxy attempts to connect to the server and then sends an operation reply telling the client whether the connection has succeeded or not. So next slide, please. So what I've set up to this point applies to the first connection attempt. In further connection attempts, the SOC's client can attempt to do zero RTT authentication, in which case the server replies with an authentication reply and requests that no further action be taken. So next slide. So let's take a closer look at what the request looks like. We've got version numbers, a major number and a minor number. We advertise the known authentication methods. We tell the proxy whether we want to use TFO or not. We tell it what server to connect to. We also include some options in TLB format. And at the end, we place some initial application data. The next slide. The authentication reply basically tells the client whether the proxy needs further authentication or not. So in case zero RTT authentication failed or was not attempted, the proxy basically tells the client that such and such method must be followed in order to authenticate the client. In case zero RTT authentication succeeded, the server tells the client via which authentication method it actually authenticated the client. Next slide, please. And finally, we've got the operation reply, which tells the server, which tells the client whether the connection was successful or not. In case it wasn't successful, it informs the client whether it was due to a reset or because the connection timed out or because the proxy did not refuse to connect to that server because of policies or whatever other reason. A field that is of a new field, a field that is of particular importance here is the initial data offset. This field actually gives the server a kind of carte blanche as to how much of the initial data it is supposed to buffer while waiting for the client to authenticate. So basically, if the client sends a huge chunk of initial data, the server can choose not to buffer it while waiting for the client to authenticate. It can just fill the initial data offset field with 0, forcing the client to retransmit the data. Now, next slide, please. Let's look at how SOX 6 typically operates in practice. This is how we expect the data exchange to look like on the wire, assuming that nothing really weird happens and that the client and the proxy server are implemented efficiently. So the client starts by initiating a three-way handshake with the server, with a proxy. After one client to proxy RTT, it sends the request along with some initial data for the server. This is when the proxy initiates a three-way handshake with the server. As soon as that three-way handshake is completed, it sends over the initial application data. The server then replies. So the total time taken for the client to receive data reply from the server is 2 RTTs, which is no worse than vanilla TCP. So next slide, please. So let's see what happens if we've got TFO on the client proxy leg. In this case, we get to shave off one client to proxy RTT. In case the proxy is on path, we have negative overhead. So we get a data reply in one end-to-end RTT plus one proxy to server RTT. This is especially advantageous in case of mobile deployments because the delay at layer 2 tends to be high. So next slide, please. So in case we have TFO on all legs, the initial SYN hopefully contains both the request and all of the data that the server needs in order to generate a response. The proxy server does something which is roughly equivalent to stripping the request. It sends the application data to the server. The server replies, and the proxy relays that data to the server. In this case, we get the data reply in one RTT. This is exactly what we would expect from TFO. So we do have one early prototype based on Shadow SOX. Some of you might be familiar with it. It's available at the link on this slide. We have also written a message library which you can use to write your own clients and servers. And that's it for me. Thank you.
Christian Uitema, I'm sorry I've not read your draft and I don't know what you have in the security section, but how do you handle replay attacks?
How do I handle replay attacks?
Yes.
What kind of, you mean replay attacks incurred by TFO?
No, basically, well, yes, to some level, but basically you have a zero RTT process in which you can send these initial data.
Yes.
Those initial data can be replayed.
Mm-hmm.
Okay. And in that case, the replay, what I seem to guess is that the replaying of those initial data will trigger a connection to the other end at a minimum, including the sending of data. So I don't know whether you have analyzed, what are the downside of it and what are the possible mitigation.
Well, yes. So TFO also has the same issues. That is why TFO is optional. The client can choose whether or not to use TFO when talking to the proxy. And it can tell the proxy whether or not to use TFO when talking to the server. Now, with regard to authentication, it basically depends on how the zero RTT authentication is implemented. So if you just use some kind of token, as in TLS 1.3, then you can indeed do replays. But if you use some kind of challenge response authentication scheme, the proxy can just issue like several challenges to the client, and then the client uses them up for connection attempts. And the client should not be allowed to use a challenge multiple times. So that kind of handles replay attacks.
So yeah, basically you need a complete description of that.
Yes, well, that is outside the scope of the draft, so we do not discuss authentication methods. We do know that zero RTT authentication can be handled in different ways, some of which are prone to replay attacks, some of which are harder to attack. So, yeah.
Well, okay. I will read it probably.
Ben Schwartz. Hi. So I was in your presentation of this material in the MPTCP working group, and so I had a chance to give a lot of comments there. And I don't want to repeat myself too much, but I'm going to repeat myself a little bit. I also had a little more time to think now, so I want to be both more positive and more negative. So more positively, I'm really enthusiastic about bringing shadow socks into the IETF and trying to figure out a way to basically fix that protocol, because shadow socks is a widely used protocol out there. It needs interoperability. There are multiple clients and servers. It does not have good interoperability today. It is not well specified, and this is a big improvement both over SOCKS 5 and over shadow socks itself.
Well, the thing is, the shadow socks protocol actually, when you strip away the encryption, it actually looks a lot like SOCKS 4. It's a stripped down version of SOCKS 4. We are not trying to standardize shadow socks. We just used it to piggyback our protocol.
I understand that your draft doesn't contain shadow socks, but it seems like what you've done here is you've identified sort of why they were unable to use or unwilling to use SOCKS 5 as their foundation. And your proposal is something that could underpin a future version of shadow socks, but it would also be sort of potentially more compatible with IETF approach. So I'm really enthusiastic about that. I'd love to collaborate on code. My team is working on shadow socks based clients and servers, and we would love to have a better protocol foundation. So
sure, feel free to shoot me an email anytime.
So I'm very enthusiastic about this from that perspective, but I also think that this protocol is extremely dangerous and should not be allowed at the IETF. Because what you've done here is you've taken SOCKS 5 and removed RTT. So why is removing RTT important? Removing RTT is important if you're speaking over a high latency network. In almost all cases, high latency networks are not secure networks. They're not networks where we would be willing to trust the link layer with our security. Particularly, they're usually over the internet. And if I understand correctly, one of your main use cases here is for channel bonding, where you're going through two routes. You're definitely going over the public internet. But this protocol isn't secure, and although you mentioned you can tunnel it over TLS, that's actually not quite true. In fact, I think this protocol is insecurable as specified because of the UDP associate. There's actually no way to set up a crypto context that handles both the TCP and the UDP side.
Yes, well, we only included the UDP associate feature because it was in SOCKS 5.
Right, so SOCKS 5 is also insecurable, but SOCKS 5 is clearly not designed for use over the public internet. SOCKS 5 is designed for and I spent a few minutes looking through the history of this. It came out of the authenticated firewall traversal working group. So it was very clear to the people who designed it that it was meant for use inside a local network that did not have access to the internet. So that was a trusted network, and it was a low latency network.
Yes, that was the use case 20 years ago.
Right. So I agree. I think it's really important to have good standards for proxying and efficient proxying out on the public internet on high latency networks. I think this is a big improvement over SOX 5, but I really wouldn't want anyone to actually deploy this on the public internet because it's insecure, and also because if we're going to rev a protocol that hasn't changed in 20 years, we should take that opportunity to look through all the different ways that we can see if we can improve it. And I think there's a lot more opportunities for improvement.
All right.
David Skadazi. So I had some comments on the list about like the encoding of the protocol, but those I think we can keep on the list. I don't want to rat hole here about bits. I think this is really good work. I totally agree that SOX v5 needs a facelift. The fact that if you, the use case I use it for is completely unauthenticated because, well, as people before were saying, yeah, it's not safe at all, but if you trust the underlying network, then it's fine. And when you're using SOX v5 in the non-authenticated mode, you have to like do several RTTs to say, oh, I don't support authentication. Oh, good, me neither, let's talk. Not very useful. So SOX v6, you could really streamline and do these things. So I really think there is an opportunity here for solving this problem, with the caveats that if you also want to tackle authentication, and especially on the wide area, that will require much more work.
Yes.
Tommy Pauly, just going off of what David said, and he didn't get into. I agree that, yeah, it's not safe, but I think there are now probably going to be more high latency links in which the RTTs matter that are potentially safe or trusted links if you're looking at home networks or IoT type networks. And so this would be very useful for doing proxying there, in which you can potentially see latencies now that you didn't see when SOX was originally designed.
Hi, I just want to respond to that.
State your name, please.
Ben Schwartz, sorry.
Thank you.
I just want to respond to that and say, you know, we've been burned many times here for trusting the link. Certainly in Wi-Fi, over and over, we've sort of been told that we have a trustworthy link layer, and we've learned over and over that it wasn't true. And so, you know, the IETF generally takes the position that you either need basically IPsec or TLS or a moral equivalent.
To clarify, Dave Skanazi, the statements, by trusted link, we didn't necessarily mean layer 2. Like IPsec was what we had in mind.
Okay, thank you.
Thank you.
But this was the last item on our agenda. So, any other questions?
No, thank you, and have an early lunch.
Okay, thank you, and see you in Singapore.